Okay, last time we talked a little bit about some of the things that are on your test, and I wanted to go back over the remaining parts here. So the uh, first thing we talked about that'll be on your test is derivatives using the limit definition. So if you go to the 2.4 notes and look at, if you go to the 2.4 notes and look at the examples A through C, those would be kind of examples you can expect to see on your test. We then moved on to our basic derivative definitions and then just a few examples of types of problems you might run into. Problems like this polynomial, x to the fifth minus 8x squared plus 7x, cube root of x, or this problem here, 1 over x squared minus 1 over x to the fifth. And all those you can just use our derivative rules for. You don't have to use the limit definition, just for the one problem where you're asked to do the definition. Okay, we then talked about some word problems where we talked about marginal functions. We looked at things like marginal cost, marginal revenue, marginal profit, average cost, average profit, marginal. And again, remember, marginal just means do the derivative. Do the derivative. And it tells us the rate of change. Okay, and then we talked in 3.1 where we introduced exponential and log functions, reviewed them a little bit. We talked about interest problems. Those two formulas there, a equals p 1 plus r over n to the nt and a equals p e to the rt. You don't need to memorize those. If you need those will be provided for you. So just two example questions. Like some of the questions I could ask you with these interests. I could ask you, hey, put so much money in at 7% compounded monthly for 10 years. How much are we going to have? So in this problem, we would be compounded monthly, so we're using this version of the formula. We put in 1200, interest rate 7%, so 0.07. It's compounded monthly, so that'd be divided by 12, and then to the 12 times 10 power. Okay, and in a second example, we asked how long would it take if we put $800 in at 6.5% compounded continuously, how long would it take to double? So now we're using this formula. So we would be putting our information in and we would have to solve that. If you go back to 3.1 notes, you'll see examples similar to those that we worked out. We then talked about derivatives with E and Ln, so you should know how to do those. And the main thing with these that comes up is with derivatives with Ln, like we had Ln of 5x cubed. We have to use our properties of Ln to break it up so we can get to just the Ln. So remember, Ln of a product you can write as a sum. So Ln of 5, and then Ln of x cubed, you can bring the 3 out, the power comes out. And so now it's in a format where we can do the derivative. So derivative of Ln of 5, that's just a number, so that's 0. 3, derivative of Ln is 1 over x. It's 3 over x is the answer there. Other than that, everything with the derivatives will come up more as a part of the problems in 3.3. As you can see here with the example x to the fourth ln of x, you can be asked to do a derivative like that, or g of x equals x squared e to the x. And some examples of the quotient rule, f of x equals x plus 2 over x minus 3, or g of x equals x squared plus 2x over x minus 5. And again, if you just go up towards the top, we did several different examples like those problems. So go back and look through the examples that we did as well for some additional ones. But those are just a few that kind of give you an idea of what to expect, what to look for as you prepare for the test. So again, if you have questions, please email me, and I'll be happy to go over those with you some, or try to help you as much as I can.